Testing 1, 2. Okay. Figure I'd go over this diagram. Okay. I'm going to choose the color. Let's see here. Let's try orange. Okay. If you follow the orange, this is the area I'm talking about here. So these coils, I don't know which way you need to wind them, but whichever way you wind them, make sure at this point you're getting a north, and over here you're getting a south, so that you can push this south magnet and push this north magnet. Same thing is going on over here. So you wind your coils in series, okay? You have a plus here, a minus there, and you pulse that to drive this system. Just make sure your winding orientation is set to give you a north here for this north, and a south here for this south. Likewise, do the same on this side. Yeah, I know, I just repeated that, but sometimes it's necessary to repeat things. So anyway, when you initiate the on cycle of the pulse, there's an on and an off portion of each pulse. On the on portion of the DC pulse to this series set of coils here, you'll create the associated poles needed on the four ends of these two cores that are shaped like a U in order to push these four magnets at the same time. Once the wheel gets moving that way, the magnets will move. And you see the green circles are indicating the position of the magnets when they land over the arms of the coil, of the stator coil, which picks up power. So this north magnet here will land over this arm of the coil here. Okay? And this south magnet will land on this part of the coil, that part of the arm, the other side of the coil, the arm, the other arm. And that will induce alternating current. What I want to point out here with this video, most importantly point out that you have a north here It's going to land here soon. Okay? Right, but right behind this north, you have a south. Okay? So after this north lands here, and this south lands here to give you power on this coil, then the next magnet will be a south behind it. So essentially you're going to have a north and a south pass over the two arms of this coil here, and followed by that you'll have a south and a north pass over the coil. And then the next pass will be a north and a south. Keeping in mind that the drive coil here is having its polarity inverted with each pulse. So going back a little bit, the first pulse will be a plus here, and a minus here. The next pulse will be a minus here, and a plus here. That function will invert the poles coming out of the core material when the coil is energized, giving you the needed necessary poles to, instead of break the wheel, continue on pushing. So as you can see, here you have a south under this core. So that means you need a south to be generated on that core to push that south. And here you have a north under this core, which means you need to create a north on that core to push this north along. Okay? That will be the case. The double throw relay will then flip that around when the wheel turns and the south has already landed here, and then the next north now comes. And you see right now, when the first turn from this north is going to move over to here. Okay, that south is going to move over to here, and then you're going to have the needed north and south over the arms of the coil. Okay, but behind this north, you have a south coming up, which means the next alignment of magnets over this coil is going to be inverted. It's going to be opposite. So instead of having this north here, you're going to have this south here, and this north will be here at the next, I guess it's 90 degrees rotation, or is it 45? 45 degree rotation. And that's fine as long as you can switch this negative up here to a positive, okay, and this positive to a negative, which will then change the polarity on these poles according to the polarity of the rotor magnet. Whereas the first polarity, the pole here, was a south to match, I'm sorry, it was a north to match the upcoming north. And then the relay is gonna flip the polarity and create this to be a south to match the south over here that's coming behind this north. I think it's a little complicated to follow that, but you can rewind it. Um, but that's how that works. I already demonstrated this working in a coreless system. Um, you know, I'll post that video in the link in this video. So I just needed to mention that. So that's what the double throw relay is doing. It's flipping the poles on the drive coil from positive to negative, and then negative to positive, and it does that 180 degrees, I believe, every 180 degrees. And that at the same time changes the poles on these cores, because you see you have um, north, south, you have a north, south, north, south setup on the rotor. Also want to mention, you can always put the rotor magnets in a three-phase alternating current array, which is also north-south, but I believe it has, um, can't remember, but it's like, it has 120-degree separation between each north-south magnet that's being placed. So this can be turned into a three-phase system as well. But for now, I'm just keeping it as basic as possible. Because when you have a three-phase system, it kind of looks like this. You know, you have a magnet here, and then here's your 90, 45. And then there's a magnet here at 120 degrees from here. Let me get that straight. I don't remember. But it's like, a north, a south, and then a gap of 120 degrees, or was it 30 degrees? And then another north and south. There's a north, and then 30 and 30 is 60, 120, that's 90. There's your 100, plus 30 is 120. That's like 120 degrees right there. There's your 90 degrees. And so there's like a magnet there. Oh, right, I'm starting to remember this. It's like that. I think that's the three-phase positioning of your, so 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 8. So there's like 8 magnets and 3 coils, or 6 arms of 3 stator coils. So you would put a stator coil right here, and right here. Oop, wait a minute, I got that wrong. Right there, And then you would offset the next stator coil. So only one stator coil would receive north-south. Okay? This is how the rotor magnets are on a three-phase generation system. And that is a 30-degree separation between north and south with a 100, is it 120 degrees? Yeah, right here. No, that's not 120. But anyway, it's something like that. The separation is, it's not 45 degrees. It's 30 degrees, 3 times. 4 is 120. Anyway, and then you have your first stator coil. All three coils are in series, and they're rectified from there. But the first, only one stator coil has north and south passing over the arms. Um, so the stator coil would have its arm kind of like that, and your magnet would be right there, landing over the arm. This is a this is when you're doing a generator in a flat design, not by putting the magnets on the circumference, but it's still the concept of the three phases showing here how you do this. North and south, north and south. You could do this on the circumference as well. And the next coil, okay, so the next coil to receive these are the magnets on the face of the disc, the rotor. And the next coil will be like, because the rotor's turning this way. So this coil here already got, north and south over the arms. And the next, it's a 1, 2, 3, 1, 2, 3 kind of system with a three-phase of it pulses like 1, 2, 3. So the next coil to receive the pulse is going to be somewhere over here. Per se, like, right here somewhere. And then you'll see this magnet here, and the next magnet here. It's turning that way, and they'll end up over the arms of this next stator coil, and so on. And then your next stator coil is like right here somewhere, and then the next pair of magnets lands over that coil. And it's like a 1, 2, 3, 1, 2, 3. So 3 pulses per 360-degree turn. That's the three-phase system. So if you wanted to do that, you could do that, on this this diagram here. This diagram shows uh, the drive magnets or the generator. They're also generation magnets. Here, the magnets are just generation magnets. They're not drive magnets. So here you see you can drive all 4 magnets by pushing them with a series wound coil over 2 U cores. You push the 4 black circles with the north-south magnets. They land over the arms of the coils. And when the next pass happens, this north and this south becomes a south and a north. Okay, and now to get to the final point of this live stream, most important note is that when you want to select the power off of the stator coils in blue, the blue circles, because it's going to have a north and then a south on one pass, and then a south and a north on the next pass, that means you have to put a rectifier coming out of the two ends of this winding. Let's say that's the, you know, it's a one-turn coil or stator coil or whatever. Just imagine it's got many turns. Those are the two ends. Okay. When you put your rectifier on there, you're going to need instead of one rectification in one way, you're going to need two rectifications in two directions. Okay? And that's what you're going to have to do to pick up the inverted pass of each north-south magnet over the stator coils. As I said earlier, first you're going to have a north and a south pass over the arm, the two arms, and then it's going to be a south and a north passing over the two arms. And then the next pass is going to be a north and a south, and so on. It's going to continue to repeat that. That's why you need to rectify in both directions, if you want to pick up the power in both directions. Otherwise, if you don't rectify in both directions, that means in one of the directions of the stator coil, as it picks up power, it will create lens, and it'll act like a brake instead of, the power won't go anywhere. It'll get cogged up in the coil. You got to get the power out of the coil. And so you have to have it rectified like this. Okay. Assuming you got both of these coils in series, and then you take the two ends of these two coils that are in series, and you connect diodes to the two ends, like so. And then you connect this diode to the positive of your battery. This diode goes to the negative of your battery. This diode goes to the positive of your battery. This diode goes to the negative of your battery. Same battery. Because when the north and south passes over the arm of this coil, both these coils, only one of these rectifiers is going to be functioning at that time. The north is going to come out here, and the south is going to come out. Let me change the color on this. Hold on. The north is going to come out the positive diode to your positive terminal of your battery. The south, this is on my hunching. I'm just having a hunch on this. Like, don't quote me on this. The south is going to go out the negative diode to the negative of your battery. Okay, and then the next pass over the arms of this coil is going to be inverted. Okay, and now you're going to have a north coming out here to the positive of they're both the same positive, the same battery, same positive, same negative. Okay, but next pass you're going to have the north come out this diode here, and then you're going to have the south go through this diode. Again, the double pole, double throw relay inverts the drive coil, inverts the poles. This is not a typical way of driving a pulse motor. Most people don't do it this way, but you can. I've done it. It works fine. If you don't have a core on your drive coil and you have a north-south magnet that you're rotating, you can only pulse it one time per 360 degrees and only harness the north of that magnet in a push fashion. And it will spin without a core. But if you have a core, come the south side of that magnet will break onto that core material and your pulse motor will not run. Unless when that south field of that magnet is approaching, you then invert your source power to that coil and thereby inverting the field it creates to now generate a south for the south that approached. That is only needed when you have a core. If you don't have a core, you could just pulse it once for the north and let the south pass by without doing anything to it. And that's kind of how that works for air cores. I just like taking advantage of cores because they create a lot of pull on the rotor magnet. And that's a source of energy that, when you have a core in your electromagnet iron, that rotor magnet's going to pull to it naturally. You don't have to provide power for that. All you need to do is provide power for when it gets there to then eliminate the iron field and convert the field from iron to a polarized field alike to the magnet that's arriving to it in order to repel it. And then that happens on the on cycle of the pulse. Anyway, I did my best here trying to describe this way of driving a motor and collecting AC power with stator coils. Hope it makes sense. If it doesn't, it's okay. I will continue on trying to make better descriptions of this. I only have 2D capabilities right now. But yeah, you can rotate a north-south magnet with an electromagnet that has an iron core. You can flip the polarity of the drive of the winding on that electromagnet and change the core polarity from a north to a south and drive the north-south magnet on. You will actually be able to drive it 180 degrees of the turn will be driven by the north of that shaft magnet will be driven by a north field from your electromagnet, and the next 180 degrees will be driven by a south field coming off of your electric magnet. And of course, at that point, the south side of the magnet on your shaft is facing the core of your electromagnet. So all that happens with a double pole, double throw relay. You can do it with transistors as well, just by mimicking the relay action of a double pole, double throw by using transistor gates. It's a lot more complicated to do it with transistors because of the flyback, and also this system is taking advantage of the flyback. It will be anyway. Um, yeah, it looks complicated, but it's not as complicated as it looks. Uh, and I hope it makes sense. And yeah, that's about it, guys. Over and out. I'll try this again another night. Thanks for watching. Oh wait, there's some people here in the chat here. Bridge rectifiers are not hard to get. Yeah, I missed the first one, but what I see it makes sense. Can cause fusion. Sometimes you lose. Yeah. Um. Yeah. Post your questions. I'll read them. And I'll make the next video with the answer, or if I have the answer to what's. But yeah, this design makes a lot of sense to me. Um, because the first time I messed with a double pole, double throw was to spin a spinner magnet that you use it to spin liquids inside of a beaker, and I made my own beaker spinning machine, and I wanted to spin it in two directions to eliminate buildup on the plates. So I would put the timer to flip a double pole, double throw relay to make the motor spin for 1 hour in one direction and then another hour in another direction. Well, through that, I realized you can also, pulse a coil, plus minus, then minus plus, back and forth, continue that. And that will flip the poles on the coil. I have not experienced any issues doing that. It runs just the same as pulsing a coil in one direction. In fact, I think it has more torque because you're pulsing in both the north and the south of the passing magnet, so you get more torque, and there's no like the magnet may pass your drive coil at a time when you're not driving it, and then it's just throwing magnetic field into the drive coil. I don't think that's good or bad. Just maybe it's a little bit of a waste, because when the magnet is passing your drive coil, and if you're not driving it in that moment, you could have whatever frictions upon your drive system take hold and slow down your rotation. So if you have continuous drive, there's no opportunity for the environment to slow down your rotation. All right. Thanks for watching, guys. Catch you next time.